Deakin University SIT 192 Discrete Mathematics Presentation 1. I'm Winnie Ang Wenling, Deakin Student ID 215316238. In this presentation, we'll be looking on question 4. A function is bijective if it's both injective and surjective. Explain why we need both definitions of injective and surjective using example of your own. You will most likely need more than one. Okay. First, let us get to know what is function. Function is for f, x maps to y. X is the domain, y is the codomain. The set of x is A, the domain, and the set of y is B, the codomain. And the definition of function is let x and y be sets. A function f from x to y, assign each element of x to exact one element in y. Functions are also called mappings or transformations. This is a function example. For f going from x to y, x is a domain and y is a codomain. Each x maps to exactly one unique y, that means x, the domain, maps to y, the codomain. Now, we know the basic definition of function. We now look into the injective function and surjective function. First, injective function is also called one-to-one function. The function states that if x is not equal to x2, then fx1 should not be equal to fx2. It means that every member of A has its own unique matching number in B, as it is as one-to-one function. One-to-many or many-to-one is not okay in this function, but in this function, we can have a B without a matching A. Second, surjective function, also called onto function. This function is a bit different to injective function. F is surjective if all y equals to y, such that fx equals to y means that every B had at least one matching A, so one-to-many is okay in this function. And now there's bijective function. A function is bijective if it's both injective function and surjective function. So there is a perfect one-to-one correspondence between the member of the sets. Means for f going to x to y, each x maps to exactly one unique y. Because bijective function needs both injective function and surjective function. In injective function, all x value goes to all y value. They cannot go to the same value and they all have to go to exactly one unique value. In surjective function, all of the value in y have to be used. And in bijective function, the size of our domain is equal to the size of our codomain. If this isn't true, then we can't have a bijective function. In other words, bijective function needs both to be injective and surjective to form a perfect one-to-one correspondence. There's a few examples here. In order to be bijective function, first the function must be one-to-one. If the function is not one-to-one, there's no need to do the rest of the function, because the function will not be bijective function. Here's the example 1. F for R to R defined by fx equals to 3x plus 4 as fx is bijective. In order to be bijective, this function must be an one-to-one and onto function. Let's start with one-to-one. One-to-one, fx1 equals to fx2 by bringing the 3x plus 4 in it will become 3x1 plus 4 equals to 3x2 plus 4. Then we divide out the 4 in both sides. 3x1 equals to 3x2, then 3 out of both sides. x1 equals to x2. Therefore, fx is an one-to-one function. So since the function is one-to-one, we continue to the next step, surjective, aka onto function. On onto, fx equals to y. By bringing in the 3x plus 4, y equals to 3x plus 4, remove the 4, 3x equals to y minus 4, x equals to y minus 4 divided by 3. Then we move the 3 to the other side to divide it by y minus 4. 3 times y minus 4 divided by 3 plus 4. And now we replace x by bringing in 3x plus 4. 3 times y minus 4 plus 4 times 3 divided by 3. And here we get by multiplying 3 to the group 3y minus 12 plus 12 divided by 3. And then we get 3y divided by 3. 3 and 3 get cancelled and we get y. So we get here the value of fx as y. We can say that fx is an onto function, therefore fx is bijective and it is satisfied the condition of one-to-one and onto function. Here's another example. Example 2. Fx equals to x2 minus 4 divided by x minus 2 is not a bijection. We have to prove that. So now let's check the function. First is one-to-one. One-to-one. fx1 equals to fx2. This is done by replacing x with x1 and x2. x12 minus 4 divided by x1 minus 2 equals to x2 minus 4 divided by x2 minus 2. We can get an answer here, so fx1 does not equal to fx2. So here we observe that fx1 is not equal to fx2. fx is not an one-to-one function, and hence it did not satisfy the condition of one-to-one. So since it's not satisfied the condition by one-to-one, we did not need to continue on the onto function. We can show that fx is not a bijection. And there you have it. Bijective function indeed need both injective and surjective function to be proved and form a perfect one-to-one correspondence. This is the end of the presentation. Thank you for your time and goodbye.